Hello students, welcome back. Let's go to final section. Absolute value equations and inequalities. This may become important in calculus too, but otherwise, I don't know. So I'll tread lightly here. Everybody knows what an absolute value is. Take the number part if positive, and then if negative, throw away the sign and take the numbers part, or equivalently speaking, put extra negative sign to make it positive. If you have absolute value equations, therefore, just the original or negative, we have to consider both of them. See? Original or negative, you have to consider both of those. And then in the end, you have to check for possible extraneous solutions. So what kind of chance are you going to see for absolute value equations in exam environment? Oh, pretty low, very low. Still, let's do maybe one problem. Okay, alright, let's consider that. 3x plus 2 is 7 minus 2x. There goes 1. And then 3x plus 2 is negative of that, 2x minus 7. There goes the second problem. So here's one possibility, and here is another possibility. For this one, okay, let's check. Flip 2x to the other side, so 5x. And then flip 2 to the other side, we have 5. Did I do this right? So we have x equals to 1. Is it valid? Go back to the original equation and check. If you plug in 1, do you actually get what you want? 3 plus 2, 5. Alright. 7 minus 2, 5. Oh, yes and yes. Good. Next. Negative of this, so this. Okay, alright, let's solve it. 3x minus 2x, so x. So right inside. Negative 7 is already there. Flip away 2, so negative 9. And there goes the solution. Does it work? Plug into the original and then please check. Negative 9 here, so negative 9, negative 27, positive 25. Now plug in here. Negative 18, positive 18, plus 7, 25. Okay, that works too. So both are solutions. And then always check your answer. Both are okay. I use color coding blue and red instead of blue and purple. Otherwise the same. The second problem here, I'll leave that to you. Do the same problem, same process, except for its elementary change of numbers. And then once you get the answers, or possible answers, do not forget to check those and see if any of them is extraneous. So we have this straight ahead, and then putting extra negative, we have the second, and then check your solution, and oh, we end up with only one solution this time. This one is okay, and the second one did not pan out. So that's how you can do absolute value inequalities. Absolute value equations, excuse me. Basically, you solve two equations. Consequently, we get two candidates. And then check. As we had in this case, both may be solutions. As you said here, only one of them may be true. And of course, there may be some cases neither, so we have no answer. That can happen too. And so much for absolute value equations. Okay, next, absolute value inequality. There are two types of absolute value inequalities. One is the absolute value is less than or something, or less than or equal to something. And these two cases are relatively important, especially in Calculus 2. So we're going to talk about those. In this case, I don't know, in intermediate algebra, quite a bit of sections were devoted to these kind of cases. And I did prepare those in lesson 3, but I don't know. I've never written any exam problem associated to these, and probably I'm not about to start. So I'm not going to emphasize these or problems, or absolute value is greater than something type. Let's stick to blue type. And indeed, both are blue types. Absolute value is less than something. Absolute value is less than or equal to something. So in this case, how do you work those out? They both become double inequalities. -7, and then this 2 minus 3x over 5, +7, like this. How do you remove the denominator? Multiply away. And then subtract away this 2. So -37, -3x, and subtract 33. Okay. Divide away -3. 37 over 3 x, 33 over 3, which is 11 as a matter of fact. So 11 x 37 over 3, or in other words, 11 37 over 3 in an interval expression. So basically, it's a double inequality problem, and we went through some double inequality in previous section. Is that what I did here? Yes, the same thing. And then as for the second problem, stop the playback and do it on your own. We have semi-inequality, so please expect brackets. Otherwise, pretty much the same. Well, did you get it? Okay, all right. I'll show you. -1 and then fraction, +1. Multiply away 9, so -9 numerator and +9. Subtract away 1, -10, 2x, and then 8. Finally, divide by 2, dividing by positive numbers, so no change in the direction. So -5x, 4, and both are brackets. Both are semi-inequalities, so we have bracket expressions for both. Easy. If you can do double inequalities, then these kind of absolute value inequalities are easy. How often did I write absolute value inequalities in exam? Actually quite a bit. Sometimes double inequalities, sometimes absolute value inequalities, but only absolute value inequalities of blue type. Only this type. This one here, well, if I have some algebra class primarily for math majors or something, then I may consider. Otherwise, hey, what's the point? So that concludes section 2. That concludes lesson 2. And please remember some important things versus less important things. Some difficult things versus some trivial things. Complex numbers are important, especially complex division. Radical equations are important, but beware, it's difficult to everybody. Linear inequalities, no big deal, so I usually focus upon double inequalities. Absolute value equations and inequalities, no big deal, so alright, that's about it.